Okay, for week 20, we're looking at what dissolves in water and also iron in just iron. And so this one, I'm not going to go through the whole thing because I think most of you guys have, it's pretty obvious. So we're going to have several, I won't have such small beakers. They'll be clear cups with plastic spoons so you can actually get into it. But we're going to add different substances to test. So I'll have just a bunch of random things. So flour, pepper, oil, salt, Epsom salt, some coffee, red wine, coconut oil, some sprinkles, who knows what else I'll bring. And you could, like, depending on what time you have, you could like dump out the water and retest different things if you want to. But basically, we want to ask the kids, does everything dissolve in water? And most kids will know that no, some things don't. And then let's ask them to make hypotheses about which substances they think they'll dissolve in water. So they're like, yeah, flour will. Pepper, I don't know about pepper. Salt dissolves in water, but does pepper? Oil, most kids know oil doesn't mix with water. Epsom salt, we've had some experiments like that. Well, coffee, when my parents drink coffee, it's all dissolved, so maybe that dissolves in water. Vinegar, yeah, probably. Coconut oil, maybe. Sprinkles, no, so just have them kind of guess what they think is going to dissolve in water and what won't. And then just do it. Start with the salt, and you're going to take just a teaspoon at a time, put it in the water, mix it up, and then let the kids observe and see what happens and see if it dissolves or doesn't dissolve. And then just talk about were you surprised by any items? So which items disappeared when they were stirred into the water? And do you think they're still there? So the salt's going to dissolve completely in the water. Is it still there? Did the salt disappear? It sure looks like it disappeared because it's completely clear. But what happened? And so kids can, some kids may know what happens, but you could ask kids, does anyone know what table salt is actually made of? So table salt is sodium chloride, which again, I brought out my molecule model, and it's sodium chloride is one atom of sodium and one atom of chloride. And when it mixes with water, it breaks these bonds. So you could pull these off. And so it kind of dissociates. The chloride is slightly negative charged, so it's going to attract to the positive hydrogen ions. And the sodium is slightly positive charged, so it's going to attract slightly to the negative oxygen atoms. And so that's why they kind of dissociate like that. So in water, when we do it, the sodium is still there, the chloride is still there, they've just broken apart, and so we don't see them anymore like a solid. And then for other stuff like coffee, kids might not know that like the coffee just filters, or the water just filters through the coffee, and that's what we're drinking. From oil, you could talk about that. Oil is, oil and water don't mix. And pepper, is kind of different. The flour should dissolve in the water completely. But the flour's not disappeared, and the flour will be cloudy, right? We know that. So the solid form you can kind of see a little bit more, versus the salt is like completely gone. Epsom salt will be the same thing. The magnesium sulfate crystals completely dissolve. Vinegar should dissolve in it completely. Anyways, that'll be the first part of it. The second part is looking at iron in cereal. So I'll have a periodic table. I forgot to grab it, but we'll have a periodic table. Let me grab my book. Oh, right here. So I'll have this book there as well, and kids could, I'll have the printouts of the periodic table. So kids can find it, and it might be kind of tricky to find because it doesn't say iron necessarily, or it's not IR, but it's listed as Fe on the periodic table, which is ferrous is the chemical name for iron. And so iron looks like Fe. And there's some fun facts in this book. If you guys have time, you can kind of look through it with the kids. But I put them just on here as well. So you could ask them what type of element is iron. If you look on the periodic table, it's in the metals. Ask them, what is iron used for? It's used in industry for train tracks and other kinds of things like that. And does our bodies need iron? And most kids or some kids might know that it does. What does our body use the iron for, and how do we get the iron? So you can just give them some fun facts. You can either do this at the beginning and give them some background information, or do this at the end. So interestingly, there's more iron on Earth than any other metal. It's magnetic, which is really going to come into play in today's experiment. And it really combines easily with oxygen to form rust. These are things kids have probably observed just in life. When it combines with sulfur, it looks like gold, which is interesting. So that's what fool's gold is. And what I think is just amazing, God used iron, this metal, in our bloodstream to help carry our oxygen around. It's also needed for enzymes to function in our body, and you need like an acidic environment to actually absorb your iron from your stomach. So if you don't have enough iron, you can feel really tired and short of breath because your bodies can't carry enough oxygen. And especially Miss April's class, April's been super iron deficient, and so she could probably speak more to that, how it feels to not have enough iron. And then we could ask kids, have you ever looked at nutrition labels before? My kids do often, and some kids may never have. So just looking at this, it kind of tells you what's in an ingredient, or what's in basically a processed food. And so you can see in here, if we look down iron, it has 18 milligrams of iron in it, which is the 100% of the daily value that's just evaluated by the FDA. So take that for what it's worth. But if we look at the ingredients here, so you could have a kid read the ingredients if we want, but whole grain wheat is in the ingredient, but the iron is added. So the iron is actually listed as an ingredient. So it's an added thing to this fortified cereal, and most cereals I think are fortified to include iron in it. It is a macronutrient, but I think it's important. You could talk about this now or later on, and I have a bigger one printed out for this, that there's lots of whole foods that iron is in, particularly liver, red meats, egg yolks, some shellfish. Fortified cereals should be like the last place that we're getting iron from, but dark green leafy vegetables, the skins of potatoes, raisins, some dried fruit has it in it. Apparently watermelon, I didn't even know watermelon had iron in it. But there's lots of really amazing sources that we can get iron from our food. And I forgot I printed this out too. You could have the kids say, look, can you look at this chemical structure? Can you find iron in this? So this is hemoglobin. This is what carries our oxygen around. And there iron is right in the middle of the structure, which is really cool. God used iron to carry our oxygen around. So today's experiment, we're going to try to see if we can find the iron in this fortified cereal. So we have this bran flake cereal that I just got at Winco, and it has 100% of the daily value of iron. So we're going to see if we can pull it out, which I'm really excited about this experiment because I've never seen this done before. So we're going to try it. So this is, let's over here. Let's see if I can find this. Dun, dun, dun. Okay. This is going to be really loud. I apologize. So I'll probably just do this with the kids' tasting. It comes from cereal, right? And instead of just bringing a powder. Okay, that's pretty well mushed up. So it's pretty well mushed up. I'm gonna add this to a baggie. That's how my baggie looks, with the iron cereal in it, and then I'm gonna add water to this baggie. And we want it, the instructions say to have, so it's a cup of cereal, and we're gonna add water and continue to mash and soften the cereal and add more water until you have a watery mush that can slosh around in the bag. So I'm guessing like thinner than pancake batter consistency is what I'm guessing it should look like. Okay, the first experiment did not work, or at least I couldn't see them with the wheat bran, and so I saw that cornflakes work better. So again, looking at the nutrition labels, this only has less iron in it, so just 11 milligrams of iron. So we'll try these cornflakes. That's the internet said to use those cornflakes. It's a lighter colored cereal, so I'm hoping that it works. I also grabbed this one that has 18 milligrams, but this is wheat checks, so I'm guessing it's gonna look the same. I don't know, we'll try it. So again, we'll take a cup of this, and we're gonna put it in the blender. This is like a NutriBullet blender that I'll bring, and grind it up super fine. Okay, so I grinded it up until it's kind of like a fine basically a powder. This is warmish water just from the sink, but it's on the warm side. And I'm hoping this will like dissolve all this stuff. So it says you're supposed to put it in there until it's like sloshy. That was a cup of cereal. We'll see. This is, I'm gonna mix this up. Water. That's like baby food consistency, but I think we want it thinner than that. Okay. That looks pretty sloshy. No, I think it needs more water. That would be 1-to-1 ratio. Water to that. Then I'm gonna try and get some iron out of it with magnets. Okay, I'm so excited and surprised that it worked. So I'm gonna show you what I did. You can see, I mean, they're teeny, tiny, teeny, but this is the iron. Ooh, let's see if I can focus it. You can see those little black dots right there. That is iron from cereal. Okay, so this is the cornflakes, which had even less iron. I'm guessing it was because the wheat checks were, or the wheat bran was too dark for you to like see the contrast. And I have it on a white thing, so I'll have like a big white binder, or this is just like a sheet of white paper, so you can kind of see the contrast a little bit more rather than on like a dark countertop. But what I did is I took, those are like freakishly strong magnets from the Heinz, and this is 2 magnets. And I could not get them apart, but my husband did, but then my kids took them back together. Anyways, you're gonna drag this along. So I have the mush. It is like a soupy sauce kind of consistency. And I'm gonna take it just along each thing, and what I'm doing is dragging it along the cereal up to the top. Then I have like most of the air smushed out, but I'm dragging it, and as I'm doing that, the iron is laying hold of them, or sticking to the magnet, and I'm drawing all that up to the top here. And once I kind of go through every layer of it like this, we're drawing all the iron to the top of the bag. And then what I did is I started over here, and then I drug it slowly to kind of collect all that iron that I put up at the top. And I was thinking, oh, it's not even working. And then I lifted it up, and you can see the magnet shavings in there. It is so crazy, the iron. Like, I wish, shoot. Can you see those moving? Look at that. You can see it better now. These magnets are so crazy strong, but you can see it. We'll drag it. Look at us drag it. That's all iron. That is incredible. I was really excited for this experiment because I just think that's really neat. Anyways, it works. Chuck's Mix cereal.